In this video, we're going to learn how to calculate the value of a logarithmic function, as long as there are no variables in our logarithmic function. So go ahead and pause the video and take your notes. Alright, it says to find the value of a logarithmic function, set it equal to a variable and change it back to exponential form. And then it gives you an example. To find the value of log base 2 of 16, first thing you need to do is set the log equal to any variable. So I said log base 2 of 16 equals x. Now I'm going to go ahead and convert this logarithm, which is what we did back in our last video. I'm going to convert it to exponential form. And I get, here's my base 2, this is my exponent to the x power equals 16. Well, most of us know that 2 to the 4th power is 16, so x would equal 4. But let's say we didn't know exactly what it would be. We would go ahead and rewrite both sides of our equation using the same base, and then we'd solve for the exponent. So we could take this equation right here and we could change it to 2 to the x power, and we can rewrite the number 16 as 2 to the 4th power. And if you remember back in chapter 6, if we have two equations whose bases are the same and they're equal, then their exponents have to be the same. And in this case, x would equal 4. Okay, so let's go ahead and practice these steps and calculate the values for the following 4 logarithmic functions or expressions. So the first thing we're going to do is we're going to set this logarithm equal to the variable x. And I'm going to take my logarithm and I'm going to convert it back into exponential form. Here's my base. I have a base 8. Here's my exponent. 8 raised to the x power is 32. Well, right off the bat, I don't know any power that I can raise 8 to get 32. So now I'm going to have to convert both sides of the equation. I'm going to have to rewrite it using the same base in order to solve. I know that 8 is a base 2 number, and I know that 32 is a base 2 number. So I'm going to go ahead and rewrite 8 as 2 cubed, and it's still being raised to the x power. And I'm going to rewrite 32 as 2 to the 5th power. When I raise an exponent to an exponent, I multiply them. So I have 2 to the 3x equals 2 to the 5th power. My bases are the same, so now I can set my exponents equal. I get 3x equals 5. And then when I solve, I get x equals 5/3. And that is my answer for the first problem. So now let's go ahead and take a look at the second problem. Again, the first step is going to be to set it equal to a variable. And then I'm going to go ahead and convert to exponential form. Here's my base, 5. Here's my exponent, x equals 125. Well, I know right off the bat 5 cubed is 125, but let's go ahead and change both sides to the same base. I can rewrite 125 as 5 cubed. My bases are now the same, so I can definitely say x is 3. All right, when we move on to the next example, we get 4, the log base 4 of 32. I'm going to set that equal to a variable. I'm going to change it into exponential form. I have 4. I'm going to raise it to the x power, and that is going to equal 32. I notice right off the bat, I don't know what power to raise 4 to get 32, but I do know 4 and 32 are both base 2 numbers, so I'm going to rewrite it. 4 is 2 squared. I'm going to raise that to the x power. 32 is 2 to the 5th. I'm going to multiply my exponents here to get 2x equals 2 to the 5th. My bases are the same, so I can set my exponents equal. 2x equals 5. And when I solve for x, I get x is 5/2. And last example, we're going to convert this to exponential form by setting my log equal to a variable. So I have my base of 64. I'm going to raise that to the x power, and that is going to equal 1 over 32. Again, I don't know what power to raise 64 to get 1 over 32. So I'm going to change my bases for both of these. I notice that both 64 and 32 are base 2 numbers. So 64 is 2 to the 6th power, and 32 is 2 to the 5th power. But now I want you to notice that I have this in my denominator. So what I'm going to do is I'm going to go ahead and move it to the top of my fraction by changing the exponent to a negative. And then what I'm going to do is I notice that my bases are the same, so I'm going to set 6x equal to negative 5, and when I solve for x, I get x equals negative 5/6. And that's how you find the value of a logarithmic function.